Hello, everyone. My name is Natalie Barth, and I'm a junior undergraduate student studying within the Sharma Lab within the Diabetes Institute. So, in the Sharma Lab, we take a look at a specific gene called ALDH6A1, and we take a look on how it is affected by obesity and metabolic dysfunction associated steatotic liver disease. And this was formerly known as fatty liver disease. So, it is the accumulation of fat on the liver. So the reason why we looked at this particular gene is because we found many human cases that link this gene to human obesity. One particular case took a look at a group of female women who had type 2 diabetes and obesity and took a look at the gene expression. So ALDH6A1 expression was decreased in the women with obesity. However, after getting bariatric surgery, their expressivity of the gene went back to normal, showing that this gene had a heavy linkage to the obesity and type 2 diabetes. So, in order to replicate what we saw in those human studies, we took a look at a mouse model. So, the first thing that we did here was we took a look at two groups of mice. We fed one a regular diet and the other group a high fat diet. Upon feeding the group of mice a high fat diet, we saw that their gene expressivity was decreased significantly, showing that there was a link between ALDH6A1 and the high fat diet. And then to take our studies a step further, we fed two groups of mice the same diet. This time, one group already had lower expressivity of ALDH6A1, and the other group had normal expressivity. But I like to again reiterate that all of these mice were fed a normal fat diet. And even with the normal fat diet, this group of mice that had the lower expressivity of the gene was still showed to have increased weight gain in both male and female mice. So even with getting a normal diet, they were predisposed to having weight gain. And then after looking at that, we took a look at their liver. They had a significant fat accumulation in the body, and we wanted to see if that was true to the liver as well. And as you can see here, all of these white droplets are fat accumulation on the liver. And those mice that had lower expressivity of the gene had a very big accumulation of fat. You can see very many white droplets all over their liver. Meanwhile, the mice that had the normal expressivity did not have those same white droplets. So they had not as much fat accumulation in their liver. And this problem is a problem worldwide within humans as well, not just the mice. Fat accumulation on the liver is a rising issue, and fatty liver disease affects about 30% of adults worldwide. So this is a very important issue, and that is where my idea comes into play. So this is something called the FibroScan app. So essentially what doctors usually do to scan the liver is they use something called a FibroScan. This uses similar technology to an ultrasound called ultrasound signal attenuation. So it sends sound waves through the liver to detect how much fat they have in the area. However, people usually only get scanned for their liver if they are showing signs that they might have fat accumulation in their liver, such as things like type 2 diabetes and obesity, or if they ask their doctor to be scanned for their liver. So, like I was showing in these mice, although this group of mice, they were eating a regular fat diet. So they were technically doing the right things. They were not eating a high fat diet. And if this was a human, you may not have any reason to believe that you need to be scanned. However, because of this predisposed gene expressivity, they were still gaining fat accumulation in the liver. So having an at-home device would be a very important thing to have in order for those individuals who may not think that they need to have their liver scanned, they can do it at home and just make sure that their liver health is all right. So this technology would be similar to an at-home ultrasound, which is already on the market. However, the at-home ultrasounds right now cannot detect the liver. They can only detect a fetus. So this technology would use a handheld device and a probe, but it would specifically be targeted to check the liver. Like I said, it measures the sound waves and sees how much it is absorbed by the liver. So if a lot of sound waves are being absorbed and you have a high amount shown that are being absorbed, that means there's likely a lot of fat in the liver absorbing those sound waves. However, if there's not a lot being absorbed and the sound waves are able to pass through the liver, that means there's likely not a lot of fat accumulating in the liver. And having something at home would use an AI system in order to remove any error. So this is very important because there can be a lot of error in where the liver is, and you don't want to try to signal out any other organs when you are specifically looking at the liver. So the AI system would be able to tell you if the probe is in the right spot in order to make sure it gets an accurate read. Along with that, the AI system would have a tracker as well. And the tracker would be very important because it is very hard to read the decibels. There could be some confusion with that, but the AI system would be able to just give a simple explanation on how your liver is doing and be able to track it over a period of time. So, those individuals that might be on the road to developing fatty liver disease could use this device in order to make sure that their liver health is getting better instead of worse. And lastly, the AI system would be able to give you some advice on ways to help your liver health in an environmental standpoint, things kind of like diet changes, exercise, some quick tips to help you get your liver health back to where it should be. It would give you this fibro score using a calendar, like I mentioned before, just to make sure that your liver health is in fact getting better. And this would particularly be important for, like I said, those individuals that might not want to be scanned at a doctor's or might not think that they need to be scanned, but are medically predisposed. So they may have parents with obesity or parents with type 2 diabetes. It would also be really good for any individuals that are on the road to developing fatty liver disease in order for them to scan their liver at home to make sure that they are doing the right steps and their liver health is getting better. In order to make this project become a reality, there would need to be a couple different components. So, first of all, on a financial standpoint, there would need to be some money put in to create a prototype of this FibroScan device. Along with that, there would need to be some money put into the software of the AI system in order to get that properly aligned with the probe that is used to scan the liver. On a human resources standpoint, there would need to be software engineers in order to create this AI system, along with biomedical engineers to create this at-home device. And lastly, I think the most important thing is once this prototype is developed, there would need to be some doctors and specialists in the area to make sure that the device works accurately. The FibroScan at a doctor's office works very accurately, and it is able to detect fatty liver disease early on compared to a lot of other devices. However, we would need to be able to make sure that the at-home device also works as accurately as the one used in doctor's offices. So I think this is how this device could help individuals worldwide. It would be able to help individuals scan their liver and make sure their liver health is doing well rather than going through this silent disease and not knowing that their liver health is getting worse. Thank you. Okay.